Hello class, welcome to this 4.6 practice video. So we're going to cover the questions that were in Canvas. So let's go ahead and get started. So this first question is saying, what in common angle do ACD and triangle ECB share? And so you just have to recognize the two triangles here. So if we look at this first triangle, we have this guy. And we have this guy. And you notice that the angle that they share is this angle here, where the black and the blue overlap. And so this angle right here, this angle is, remember when we label that angle, it's ACE, and that's what this angle is. Remember, so when you name an angle, you usually need three letters that accompany that angle. And basically, as you trace the angle, that's the order that you go in. So you could say ACE or you could say ECA. Either one is correct. All right, so the angle that they share is angle ACE. And then for example 2, what is the common side that the following two triangles share? So again, if we look at the two triangles, we have this one. And we have this one, and you can see that they seem to share, where the blue and the red overlap, they seem to share this side, and this side is AD, so they share AD, line segment AD. And there you go, there's your response. Question 2, again we got two overlapping triangles here, and we just want to, and notice that when we separate these two triangles, we get this one and this one. Okay, so we separate and we draw pictures, and then we're basically filling in the proof. So we have ED is congruent to ED. Whenever you see something like this, where it's the same side, right? They share the same side. That's this guy right here. You see ED and ED, they share because originally they ended up sharing this side when they overlap. This is a D here, by the way. And so because they share it, that's known as a reflexive property. A reflexive property is when it's a side or something is congruent to itself. So this right here is a reflexive property. In this case, reflexive property of congruence, or just reflexive property. And so, okay, so now we have that these two are clearly congruent to each other because they're the same side. They're exactly the same thing. And they tell us that, well, we have these two tick marks, and so on. And then we have this angle is the same as this angle based on the drawing, right? And so now if you look at those two triangles, they have to be congruent because we have a side corresponding to a side, an angle corresponding to an angle, and then another side corresponding to another side. So this is a prime example of side, angle, side for both triangles. So those two triangles are congruent by side, angle, side. Now angle A is congruent. So now that you know that these two triangles are congruent, then you know that any two sides on this triangle are congruent. So for example, you know that this side is now congruent to this side. Okay, when you do this, when you label the sides that are congruent to each other or the angles, that's known as using CPCTC. Remember, that stands for corresponding parts of congruent triangles are congruent. So we know that these triangles are congruent, hence congruent triangles, and therefore any parts that are corresponding are congruent. And so if you look at this triangle, these two blue parts are corresponding, and therefore they're congruent. Similarly, angle A is corresponding to angle C because they're the same angle. And so because those two parts are corresponding and these two triangles are congruent, then those two parts are congruent. So this is why it's called CPCTC. Okay, so angle A is congruent to angle C in this diagram by CPCTC. All right, so we're given that AB is congruent to CB, which is this part right here. And so now we can say that triangle ABE is congruent to CBD. So we're looking at Let's go ahead and focus on the triangles that we're concerned with now. So before we talked about AED, now we're talking about ABE. So we're talking about this triangle. And then CBD. So now we're talking about this triangle. Okay, so those are the two triangles we're concerned with now. And so now that we know that these two angles are the same by CPCTC, and we clearly can tell from the diagram that those two sides are the same. Therefore, by side, angle, side, we can tell that those two triangles are the same. Side, angle, side. So therefore, those two triangles are congruent by side, angle, side. Okay, so hopefully that was you were able to determine those answers there. But in any case, we're going to go ahead and move on to the next question. So question 3. So fill in the blanks of the proof. So we have two triangles here. We just want to fill in the proof. So we want to prove that BC is congruent to DC in this diagram. All right, so what do we know? Well, we know that AC is congruent to CE. And so when you have a diagram, I would definitely draw it out on paper and then label the parts, because this is going to help you with the proof. So we know that AC, which is this guy right here, is congruent to CE, which is this guy right here. So those two are congruent. And they said that this is perpendicular. That's the symbol for perpendicular. Perpendicular means 90 degrees. So that means that AB makes a 90-degree angle to AC. That's what they're saying there. Okay, so those are 90 degrees. And similarly, DE makes a right angle with CE. So this is DE, this is CE. Okay, so those are right angles. So that's the information that they tell us. So in this question, they're saying, well, AB is perpendicular to AC. Well, that's given, right? That's given in the problem. They told us that right here. Okay, number 2. So we want the definition of perpendicular. So that's exactly what we did. Because these two are perpendicular, that means that they make 90-degree angles, which is exactly why we have right angles. We have right angles right here and right here. Okay, so that means, because that's the case, that means we have two right angles. What are my two right angles? Well, angle BAC and angle DEC. Those are my right angles, right? Those make those right angles there. So BAC and DEC, which is, or I guess they call it angle A and angle E. So you can also call it angle A and angle E. That would work as well. Okay, so we got angle right here. So it's angle A and angle E are right angles. And that's the definition of perpendicular. And so now, because they're right angles, and that means that they're both equal to 90 degrees. And if they're both equal to 90 degrees, then that means that they're equal to each other, right? And so those two right angles are congruent, which is why they put that here, because they're both 90 degrees. And so so for this guy, what they're looking for is all right angles are congruent. So all right angles are equal to 90 degrees and therefore are congruent. Number 4, we have another given statement. So what's another statement that's given? Well, it's this guy. AC is congruent to CE. That was given. All right. For the next one here, we have angle ACB is congruent to ECD. So ACB is congruent to ECD. So that means we're talking about ACB, ECD. So those two blue angles. Notice that those two blue angles cross. They cross each other, right? So at this point, and so they touch at this point, and these are called vertical angles when they look like this. So when I call this like the X angles because they kind of form like an X, and the angles that are opposite on that X, those are my vertical angles. Okay, so those two are my vertical angles, and so they must be congruent. All right, so this is vertical angles are congruent right here, otherwise known as the vertical angle theorem. All right, and then the triangle ABC is congruent to EDC. So we're talking about these two. So yeah, these two separate triangles. Why are they congruent? Well, if you look at it, we have now an angle, which is the right angle here. We have a side and an angle, the vertical angle, and then we have here another angle, side, angle. So these two triangles are congruent by angle side angle, or ASA. All right, so now we're using the CP/CTC. Because we know that the two triangles are congruent, that means any two corresponding parts have to be congruent, which means that we're trying to prove this, right? Which means that this part, now we know that this part has to be congruent to this part because those two triangles we established are congruent. So because they're congruent, now that means that those two are the same. And so that's called CP/CTC. All right, so that's the proving statement. Whatever you're trying to prove always goes to the last statement right here. So whatever you're trying to prove always goes last. So BC is congruent to DC. All right, that takes care of that proof. All right, fourth question. We have for each set of triangles, identify if they're congruent by SSS, SAS, AAS, ASA, or HL. Okay, so we're just going to list those out. So triangle YXW. So we have YXW. So that triangle and this triangle, right? So notice that they overlap. They share this side, right? Which means that those two are congruent there, okay? So we got a side that's congruent. We also know that they're right angles, right? Because it says that here. So they have right angles here. So they're right triangles. All right, so we have that. And we also have that this side is congruent to this side, right? So given that, well, then that means that those have to be congruent by SAS, right? Or SAS, because they share that same side on the bottom. So side, angle, side. Remember when they share that side, we call that reflexive property. So here, those two triangles are congruent by SAS. All right, triangle ABC. That's this triangle right here. And triangle DCB. Oh, it looks like they share this side right here, right? Because they share that side, I'm going to put a tick mark there. That's congruent to itself, reflexive property. And then we also know that this side is congruent to, or this angle is congruent to that angle. This little angle here is congruent to this little angle here. And so if we were to draw these two separate triangles, I'll go ahead and try to draw the best I can. So the black triangle here on the left and the green triangle here on the right. Then we can kind of see, well, okay, this angle corresponds to this angle. This little angle corresponds to this little angle. And then they share that top side. So this is clearly angle, side, angle, angle, side, angle. So these two triangles are congruent by ASA. Okay, so that takes care of that one. Let me erase these triangles because we're going to need a space for number 3. Okay, so for number 3, we're given that EJ is parallel. Remember that symbol means parallel. Okay, which is why they, so that means parallel, which is why they used the arrow here. Okay, so they're saying that this is parallel to that, okay? All right, and then they said that EG is congruent to HF. So they're saying that this whole side is congruent to this whole side. Okay, so I'm going to put a tick mark here, and then here. Okay, so it's kind of hard to tell, so I won't actually draw it because these triangles are overlapping, so it's kind of hard to tell. All right, let's look at the angles first. So if we look at these two, if we look at this line extended out and look at this line extended out, and then we look at this, well, now we can tell we have two parallel lines crossed by a transversal, right? This is chapter 2. Remember chapter 2 on parallel lines? So this is chapter 2 when we did parallel lines. So we know that this angle has to be congruent to this angle, and because those are corresponding angles. And so corresponding angles have to be congruent. And so now, in fact, what I'll do is I'll make this the black triangle, and then I'll make this other one a green triangle. Okay, so I can kind of draw both of them separately. So we have this black triangle, EJG, and then we'll draw the green one below it. Okay, and so these ones are the ones that were parallel, right? And these ones were the ones that were parallel. And now we know that this is congruent to that because they told us that here, right? So those two sides are the same. And now we just established that these angles are the same because they're corresponding angles. Okay, so now we know that those two angles are the same. And so now let's go ahead and analyze another part of this. Again, based off of parallel lines, we can extend this out. And when we do that, we have another transversal right here. And so for this transversal, notice that this angle is the same as this angle. Those are also corresponding angles. And so this angle G is the same thing as this angle H. So that means that these two angles are identical. And so now, based off of these triangles, you can see that, well, these two triangles are congruent by angle, side, angle. Angle for this red one, side, angle. So these two triangles are congruent by ASA. All right, so using a little bit of chapter 2 to be able to solve that problem. Okay, question 5. For each set of triangles, name the pair of overlapping triangles in the diagram. To answer, type in the 3 vertices that make up the triangle. Okay, so you just write down the vertices, the corners. Remember, order matters when writing congruency statements. Okay, so for this one, we're looking at given LP is congruent to LO, so LP, LO, and then we're given PM is congruent to ON. All right, so that's basically the information they gave us. And we want to figure out triangle LNP is congruent to which triangle. So we're looking at triangle LNP. That's the triangle we're focusing on. Okay, so what triangle is this congruent to? Well, because we know that these two parts are congruent, right? We know that these two are congruent. So this side has to be congruent to this side, right? Based off of segment addition postulate. So like if this were 5, this were 5, this were 3, this were 3, well, they add up to the same thing. 5 plus 3 is 8, right? So those two sides are the same. So we know that that's the case. So let me draw this triangle. Okay, so we got L and P, and we just said that this, and let's draw this other triangle, right? This one right here. And that's LOM. And so we just said that this is congruent to that. So basically this part right here is congruent to this part right here. Okay, so those two are the same. And we can also tell that by reflexive property, they share this angle because they overlap. So that angle is congruent to itself, and that angle is there and there. That's angle L, right? Angle OLM. So by reflexive property, that angle is the same. And then we also know, let's see here. We also know that, and let me try to draw this a little better. Okay, so we also know that this side right here is congruent to this side over here, right? Because they told us that in the diagram. So this part right here, and I'll put that as a double tick, this part right here is congruent to this part right here, based off of that diagram. And so now we can kind of tell that this is going to be a side, angle, side. Side, angle, side. And so now we can tell that those are definitely congruent. And so the answer here is, well, LNP in this example is congruent to, remember you got to keep the same order, right? So if we use LNP, L corresponds to L, right? So this has to be L. And then N, angle N, corresponds, this angle right here corresponds to angle M right here. And then angle P right here corresponds to angle O. So this is LMO. And that's the right order that you should be writing it in. So triangle LMP is congruent to triangle LMO. All right, let's look at number 5. So we have these two triangles, right? So this is, I'm going to do this as a black triangle. I'll make this one the blue triangle. And we'll draw them separately because it helps to draw them separately. Okay, so now because these two, this part is congruent to this part, and this part is congruent to this part, that means that these two sides have to be the same. So AF has to be the same as EB. So let's label this with a tick mark. AF and EB are the same. Okay, so those two correspond to each other based off the diagram. And that's by a segment addition postulate. They add up to the same thing. Next, we know, let's see here. All right, so next we know that because we have an isosceles triangle here, this right here is an isosceles triangle. How do I know that's an isosceles triangle? Well, because it has two of the sides the same, right? This side is the same as that side. And by the isosceles triangle theorem, that means that these two angles, this one and this one, have to be the same. And so notice that this first angle right here, this one on the right in red, is this angle F, right? So that's this angle right here. And this angle on the left, E, right? That's this angle right here. So those two have to be congruent because that's an isosceles triangle in the middle. All right, so we got an angle and a side so far. So now we're going to need another side, hopefully, or maybe another angle. But I don't think we're going to need it. We're going to have another angle here. So what's the next thing? The next thing is, well, we know that this is congruent to this, right? So these two are the same. And we know that this is obviously the same because it's congruent to itself, right? So this is congruent to itself. And so therefore, if I were to add this, that's going to be the same as if I add those two together, right? It doesn't matter which ones I add on the other side. They're going to be the same side. And so now notice that this corresponds to this blue side here, right? So this has to be congruent as well. So this is congruent. And then this other side corresponds to this black triangle, right? And so that has to be congruent as well. So there you go. So now we have if you look at it, we have a side, angle, side, side, angle, side. And there you go. So these two triangles are congruent by SAS. So now we established that they're congruent. What's the right order? Well, okay, so they said AFD. So that means A has to do with, in this example, A has to do with B, right? So the first one is going to be B. And we know that angle F right here has to be the same as angle E. So the next one is going to be BF, right? Because we're doing AF, and so, oops, I said F. I meant to say E. So the next one is AF, and so it's going to be BE, and then it says FD, so that's EG, right? Going in that order. And so this is going to be BEG. All right, so the order is BEG for that example. Now let's look at the next one, number 6, VUY. So we're looking at, let's see, we're looking at VUY for the first triangle. And so if you look at that triangle, we can kind of compare it to this triangle right here, right? That's what we're trying to do. And so clearly they share this side. So let me draw it here. So this is U, V, Y. U, V, X. Okay, so they clearly share this side. So they have to be congruent to each other and there, right? UV is the same side. So that's the reflexive property. And we know that this angle, which is this one right here, angle V, is congruent to this angle on the black triangle, which is angle U, okay? We also know that this, let's see here. Let me look at that other angle. Hold on. Okay, so they tell us that this angle right here, which has to do with angle U, is congruent to this angle, which is angle V right here. Okay, so we can clearly see that we have a angle, side, I should use a different color here, angle, side, angle, and then angle, side, angle. All right, so we know that those two triangles are congruent by ASA. All right, so then what's the right order? So the right order is, so we have VUY. So VU corresponds to, in this case, because remember V is this blue angle, right? So that's going to be U. So UV. And then we're going from this, let's see, it says, the question says VUY, right? So VUY, so that means we're headed from the single angle down. So that means single angle down. So it's UVX. So you just got to make sure that you do the right order based off of the order they say on the left side. All right, that is it. That is it for the questions, guys. I hope you found this useful. And as usual, I'll see you in the next one.